Hello friends, today we will see the curve tracing when the curve equation of the curve is given in polar form. So before we start, we should understand what do you mean by a polar form equation. So in polar form, uh, the plane is represented initially by a pole. So a point is called as a pole. Okay, and then we are taking a line that is passing through this pole. So this line which actually represents your x-axis in the Cartesian form is called as an initial line. Okay, and let us take a radius vector, that is r. So that r initially is coinciding with the line. So this is r. So initially it is coinciding with the line. So it is making the angle theta equal to 0 with the initial line. Okay, and gradually then this r is rotated about this pole in anti-clockwise sense. Okay, so when r will be here, okay, it is making theta equal to pi by 2. So the angle theta is pi by 2. It is in anti-clockwise sense. Then this is theta equal to pi. Okay, and this is theta equal to 3 pi by 2. And finally you reach again to theta equal to 2 pi, or same as 0. So in polar form, the lines are recognized by means of the angle, okay, made with the initial line. For example, if I want to find out the equation of this line, okay, this line, this is actually y equal to x line in Cartesian form. Okay, in polar form, this line is making angle theta equal to pi by 4. So instead of this, we will call this line to be theta equal to pi by 4. Right? So for example, suppose I want to find out how this line looks like. Say theta is equal to say 3 pi by 4. Theta equal to 3 pi by 4. So I will find out actually is the angle about the pole. So this is pole. This is pi by 2. Right? And where will be 3 pi by 4? So it is something like this. Right? Okay. So this is theta equal to 3 pi by 4. So this way the lines are recognized by using the angle made by the line with the initial line. Okay, and they are always taken in anti-clockwise sense. Fine. If you want to them to be in clockwise sense, we will say, so suppose for example this, okay, and this is the 30 degrees angle, say pi by 6. Then we will write this as theta equal to minus pi by 6 line. Fine. So clockwise sense the angle becomes negative, anti-clockwise sense the angle is positive. Okay, so this one thing you should remember about the pole. Now another thing is important in this polar form. So this is some preliminary things. Now what kind of equations they are represented in polar form? So see, sometimes the equations are very difficult to write down in Cartesian form. Okay, such kind of equations are usually denoted in polar form. Okay, and here we are considering a special class of equations. Okay, in polar form, like cardioids, Rhodes curves, etc. Okay, fine. So how we will trace this curve in polar form? So basically now here the curve is a function of, I mean, r is a function of theta. So in polar form, the equation of curve is r equal to f of theta. Okay, so r depends on theta. So this kind of equation you will have. Then we will go in a usual way. So first point, symmetry. Okay. So if theta replaced by minus theta, okay, if theta is replaced by minus theta and there is no change in the curve in the equation, there is no change in the equation, then the curve is symmetric about the initial line. Remember, then the curve is symmetric about initial line. That is, the curve is symmetric about theta equal to 0 line. That is theta equal to 0 line. Okay. Now one thing you should note here, that this initial line is actually like a x-axis in your Cartesian form. So curve is symmetric about x-axis, so you can visualize that part. Okay, and so the curve is symmetric about theta equal to 0 line, that is initial line, is just look like a curve which is symmetric about x-axis. Okay. Next, if r replaced by minus r, okay, r replaced by minus r, and equation does not change, then the curve is symmetric about pole. The curve is symmetric about pole. Fine. So this is, we will call as A part. This is B part of symmetry, and now C part, theta equal to pi by 2 line. Okay. So the rule is like this. If r replaced by minus r and theta replaced by minus theta, if r replaced by minus r and theta replaced by minus theta, both are replaced and there is no change in the curve, and equation of curve is unchanged. Okay, or so there is an or for this particular part, or if theta replaced by pi minus theta, okay, pi minus theta, and equation remains unchanged. Okay, equation is unchanged. Then the curve, so either of these case will happen, the curve will symmetric about y-axis. This implies symmetric about theta equal to pi by 2 line. So theta equal to pi by 2 line is same as your y-axis in Cartesian form, right? So So these are the rule about symmetry of a curve in polar form. Okay, let us see the next part. Now we will just proceed as it is, as we are proceeding in the tracing of curve in Cartesian form. Okay, so we will see that whether the curve is passing through pole. So second point, check whether the curve is passing through pole. Passing through pole. Now here what you can do is you find out the value of theta for which r is equal to 0. So find theta for which r equal to 0. Okay, if such theta exists, definitely the curve is passing through the pole. If such theta exists, then curve is passing through pole. Okay, what we will do after this, if the curve is passing through pole, we will try to find out the tangents to the curve at the pole. So third is tangent to curve at pole. Okay, tangent to curve at pole. Now how to find out this tangent to curve at pole? So it's a very simple procedure. What you do is you simply put r equal to 0 in the given equation. So let me write down that procedure over here. Procedure. Okay, to find the tangent to the curve at pole, put r equal to 0 in given equation and solve for theta. Okay, whatever the theta you will get, those lines will be the tangents to the curve at pole. Okay, so this is the procedure. Next, fourth point. Okay, now what you do is you show a table. Okay, you form a table. So form a table. Right? And what kind of table you form? So the table will contain of different values of theta and r. So table for different values of theta and r. Okay, right? And with this table, then you can easily trace the curve. Okay. Another thing here we require sometimes is that, so let me explain that over here. That is to find angle phi. What kind of angle is this? To find, so point. Sometimes this is also important. To find an angle phi. Okay, now what is this angle is exactly? See, this is your pole. This is pole. Okay, this is the initial line. Right? This is theta equal to pi by 2 line. Suppose there is a curve like this. This is a curve. Okay, and then this is the radius vector. This is r. Okay, now at this point, suppose you draw a tangent to the curve. This is the tangent. Okay, at this point you have drawn a tangent to the curve. This is tangent. Right? Then the angle between the radius and tangent, the angle between radius vector and tangent is called as phi. Remember, this is your theta. Okay, and by simple geometrical calculations you can find out this phi. I directly give the formula for this. The tan phi is given by r into d theta by dr. Okay, this is the formula, or you can write down this as r into 1 upon dr by d theta. Okay, so this is quite useful, right? So in sometimes you will require to find out this angle phi. Okay, and with all this information then you can easily trace the given curve in polar form. Okay, so I hope you have understood this. We'll see the example of curve tracing in the next video. Thank you.